All right, good morning, everybody. We're working on starter number 17. For those of you taking the test, I hope it went well. So we're working on the Lewis structures for lithium. We already established in the class, because we got started here a moment ago, that lithium is in group number 1. So how many valence electrons does it have? 1. So when we go to put that on there, we'll put 1 dot. Now actually, it really doesn't matter. If you wanted to put the dot on the side like that, that's fine. The idea here is lithium has 1 electron in its outer orbital. Okay, now beryllium. What group is beryllium in? It is in group number 2. How many valence electrons does it have? 2. So when we do that, we're going to put 1 up here and then 1 over there. And like I said, if you really wanted to, you could put 1 on the top and 1 on the side, but it's, there's always exceptions to rules. So this is just a shortcut method for us instead of having to draw out all the electrons like we did last unit with the Bohr model. Oxygen, a nonmetal. What group is oxygen in? It is in group 16, thank you, 16, which means it has how many valence electrons? 6. So now when we go to do that, we're going to put 1 up here, 2, 3, 4, then 5, and 6. So that's going to be the Lewis structure for oxygen. Now what that tells us is we're going to find out a little bit later, it has 2 paired electrons. Those 2 electrons are happy in their orbitals. These 2 electrons, they are unhappy. They're really going to try to find a partner to hang out with. Let me erase that so it doesn't confuse it. Anyway, so there's oxygen for right now. And then lastly, fluorine. Fluorine is over here. What group is it in? 17. So how many valence electrons does it have? 7. So 1, 2, 3, 4, 5, 6, 7. Fluorine has 3 pairs of paired electrons. There's 6 electrons that are pretty happy. This one is very unhappy, and it's going to very aggressively try to get a partner. That's why fluorine has the highest electronegativity. It really wants an electron. Okay, I think we're done with that. Over here, label if they will gain or lose electrons to become stable. So what's lithium going to do? Gain or lose an electron? It's going to lose that electron. So whoosh, it's going to lose L-O-S-E. It'll lose an electron. Okay. How many electrons does it lose? Lose 1 electron. How about beryllium? It's going to have to lose 2. Okay, so it loses 2 electrons to become stable. When beryllium does that, when it loses those 2 electrons, it thinks it's helium and it's very happy. However, it will have a charge. Oxygen. Now we're on the other side of the chart. Is it going to be easier to lose 6 or to gain 2? It's going to gain 2 electrons to become stable. And then fluorine, how many does it need to lose or gain to become stable? It needs to gain 1. So the next question is, what is their charge when they become ionized? So when lithium loses this negative electron, what does its charge become? Okay, are you sure? So you like lithium ion, I'm positive. Okay, all right. So over here, we're going to, what do I got to do here? Oh, yeah. So we'll put lithium, we'll make a lithium plus charge right there. It'll be +1. Now, what will happen is when we do the unit test on this, what we tend to do when we draw the Lewis structure for lithium ion, we tend to do this. This isn't a rule of chemistry, but it's how we do it at Buchanan High School. We'll write lithium symbol, and then we're going to put a bracket, a square bracket around it, and we're going to put the plus sign over here. Because that's going to tell us, hey, this ionized, its Lewis structure was something else, but since it lost an electron, it's like this. So I don't want you to be surprised when we have those on the test. How about beryllium? What will its charge become when it gets ionized? Positive what? 2, because it's going to have lost 2 electrons. So again, we'll write beryllium symbol. Let's put a square bracket around it, and we're going to put +2 over there, because that's just letting us know that is now the new Lewis structure for beryllium ion. You got the symbol, and that just lets us know at Buchanan High School that we've ionized it. Oxygen over here. So what's its charge going to be? Oh, first off, it needs to gain 2 electrons. So I'm going to redraw this off to the side because I'm going to put oxygen over here. Now what we'll do on the test and stuff, So it's going to gain 2 electrons. I'm going to draw those 2 electrons as X's just to designate that they came from somewhere else. So what's oxygen's charge going to be when it gains 2 negative electrons? It'll be -2. So that's how we'll tend to show on the test if we've got oxygen ion and the Lewis structure for it. Now this one makes sense. In fact, we may not even put the brackets around it necessarily because we can kind of see the Lewis structure. It's really helpful over here so we know that we've taken something away. And lastly, fluorine. Put fluorine up here. And let's see, it looked like this before we started. And so it's going to gain 1 electron. What does its charge become? -1. So I'll have to check. I can't remember if we put the brackets when we've got a full set. Fluorine now thinks that it is neon. It's very stable, it's very happy, but it does have this -1 charge that's going to draw it towards it'll draw it towards positive charges. What do we call atoms with that are cations? Which ones are those? Plus charge or minus charge? Oh, duh. I already have it labeled there. Yeah. So these 2 here are cations. Cations. And these over here, these 2 were big negative sign anions. Okay, so that helps out. And didn't I have wasn't there a little cartoon that I had on one of those things? I just realized that. What did it say about cations are positively? Okay, no, it was really dumb. I lost. Okay, I'm not going to go on there. So, end of our starters. Thank you very much. Signing off.